Okay, so welcome back. Hopefully you went and played with that PhET simulation and you have a pretty good idea on those 5 basic shapes we're going to be using. So now the hands to paper part, and you should have a sheet of paper out so that you are drawing these along with me and determining them. So SiCl4, so silicon is 4 valence electrons. So I'm going to do the Lewis diagram first. Silicon has 4 valence electrons and each chlorine has 7, which means it can make a single bond. Single bond, 3 lone pairs. Chlorine, single bond, and 3 lone pairs. So now if we're using the ACS method, when we talk about the central atom or the silicon, the central atom has 4 single bonds, or X4, no lone pairs. So you can put E0 or just AX4. So the shape associated with that is tetrahedral. So when we go to draw tetrahedral, remember it's 4 bonds coming out of our central silicon. 2 of them are flat on the page in a V shape. So SiCl, Cl. One of them is coming out of the page. That's our wedge or diving board. And then the 4th one goes into the page like that. And I put them off to the side here as well. If you find mine pretty messy, there's our nice tetrahedral silicon tetrachloride. Okay, SF2. So Lewis diagram for SF2. Sulfur is group 16, so it has 6 valence electrons. That means 2 lone pairs and 2 bonding. And each fluorine has 7. 3 lone pairs and a bonding. 1, 2, 3 lone pairs and a bonding. So how do we explain this shape? Using our ACS method, the central atom has an X of 2 bonds and 2 lone pairs, AX2, E2. So when we think about shape, you can visualize this. The sulfur has 2 bonds coming out of it. Are they linear, straight across from each other, or bent? Because of those 2 lone pairs, they each occupy space. Valence shell electron pair repulsion. That pushes the single bonds down into a V shape. So here it is. 2 lone pairs sitting on top, pushing down into a V shape the other 2 bonds. So that is its 3-dimensional drawing as well. S in a V with the fluorines. If you're naming these, you should be able to write down the names as well. Tetrahedral and V shape, or bent or angular. They all work. Okay, PBr3. So Lewis diagram for PBr3. Phosphorus is in the same family as nitrogen, family 15, or 5 electrons in its valence, and each bromine has 7. 1 bonding and 3 lone pairs. 1 bonding and 3 lone pairs. 1 bonding and 3 lone pairs. Okay, we've satisfied the octet rule. Phosphorus has 8. All the bromines have 8. Now we need to draw this thing 3-dimensionally. Looking at ACS. The ACS for this is central atom. The phosphorus has 3 bonds and 1 lone pair. So you can either memorize these or visualize them. So that phosphorus has 3 bonds and a lone pair. I usually put the lone pair sitting up top to help me figure out my shape. Now I've got 3 bonds. With that lone pair taking up this region of space, that means the other 3 get bent down. One of them can be flat to the page. One of them is coming out of the page, and one of them is going into the page. So it's like you're drawing the bottom half of a tetrahedral with a lone pair sitting on top where that single bond is gone. So that's the shape of our trigonal pyramidal. Okay. BH3. Okay, here's boron the moron. So hopefully you remember what's unique about boron. It only has 3 orbitals, 3 electrons. Each one can make a bond with hydrogen. So this is an exception to the octet rule. It does not need 8 to be stable. It works with 6, OCTET, octet rule. So how do you draw this shape? Its central atom has 3 singles and no lone pairs. So boron has 3 bonds and they spread out equally. Valence shell electron pair repulsion. They're all 120 degrees from each other, and it's a flat plane or planar, so we call it trigonal or 3-cornered planar. We don't need to use any stereochemistry to represent it because they all fit flat on the page or in plane with the page. Okay, we have 3 more left to do, and then we're done the lesson on shapes. CH2O. So carbon, 4 bonding electrons. Each of the 2 hydrogens has 1, and oxygen has 2 lone pairs and 2 bonding electrons. So we are making a double bond. So if I just represent this structurally, C double bond O, H, H. Now, how do we represent this with the AX method and 3D? So our central atom is the carbon. So carbon has 1 single bond, 2 single bonds, and one of these is a single, and then the other one is a double or a second bond. So it's an AX3 for the 2 singles and then the third single bond. So what is the shape for an AX3? This would be like boron the moron. It would be a trigonal planar. So if we could just draw those single bonds, it would be C single to an O, to an H, to an H. There's your shape. And then we add in the double bond, but it doesn't really affect the shape. Okay, so trigonal planar. Each of these bonds is the same at 120 degrees, flat planar. Okay, C2H5OH, Lewis diagram, carbons bond to carbons. There's our 6 remaining, H5, 1, 2, 3, 4, 5, and then we have an O with an H hanging off of it. Okay, how on earth are we going to draw shape to this? So we have 3 central atoms, and this is about as hard as they get. So we've got a carbon here, and an oxygen. So we could call it C1 and C2. So AX method, C1 is an AX4. It has 4 single bonds. C2 is an AX4. It also has 4 bonds. And oxygen is AX2, 2 singles. So here is a single, here is a single, and 2 lone pairs. So really we have 3 shapes to look at. Tetrahedral, tetrahedral, and a bent. So to draw this, we are going to go carbon with its tetrahedral, so that has a V built into it. Oh dear, one coming out. I need my eraser. This will be the first of a few mistakes I'm sure I'll make. Okay, get rid of that. So there's my CH3. And then this fourth bond is attached to the next carbon. It's also got a tetrahedral. So I could make this my V, so V, V, and then I need one of them coming into the page and one going out. And we'll call both of those our hydrogens. So 2 hydrogens, 1, 2, 1, 2, and then this carbon takes off to an oxygen, which has 2 lone pairs and an H, and that is a bent shape. So we've got our bent and our 2 tetrahedrals. So this is drawing a 3-dimensional representation for tetrahedrals and a bent. Tricky, tricky. And our last one, CH3COOH. So the CH3 you already know as a Lewis diagram, CH3 bonded to a carbon. And remember, this COOH represents a C double bond O, OH. So again, we have 3 central atoms. So we'll call this carbon 1, carbon 2, and an oxygen. So what's going on here? Okay, so first one is an AX4 for the C1. Our C2 has 1 single bond. Here's a single, and here's a single. So it's an AX3. Plus it's got that double bond, but remember the double doesn't really change the shape. And then our oxygen is an AX2E2, the same as above, it's a bent. So we've got a bent, we've got a tetrahedral, and AX3 is trigonal planar. So we got to draw this thing. Okay, C, we'll make our V. And we'll put a hydrogen going into the page, a hydrogen coming out of the page. And then we've got bonded to our second carbon, which is a trigonal planar. 3 bonds equal angles. And this one is a double, C double bond O to an O. And then the last oxygen is bent to an H. So there's our 3D or stereochem for a trigonal planar, tetrahedral, trigonal planar with 1, 2, and a third single bond. Remember, we ignore the double for our shape. And then a V around the oxygen. Okay, that's it, ladies and gentlemen. Tricky, tricky. So in your study guide, there's 2 pages to practice these, page 122, 123, and then a third page with some challenging ones. I will put the keys online to these. Practice them. Practice makes perfect. If you're struggling, hide the answers and do them a second time. Okay? Good luck, and I suspect some of you will have some questions for me, and we'll work through those, so don't panic. Just try your best.